think of an industrial robot, what comes to mind? Maybe an assembly line with a big robotic arm with a gripper at the end? Yeah, that's definitely what comes to mind for me. But what kind of design concerns do we need to think about when it comes to these mounted robotics applications? Real time awareness? Perception capabilities? Precise motor control? Yeah, all of that and more. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Rajan, Sharma, and Rafael Marengo from Analog Devices and I talk about the challenges associated with motor control, industrial vision, and real-time connectivity for industrial robotic designs. We also investigate the variety of solutions Analog Devices offers for mounted robotics designs, and the role that Gigabit Multimedia Link, or GMSL, plays in these applications. And before we get started, don't forget to click that link. There you can find even more information about this topic from Analog Devices. Hi, Rajan. Thank you so much for joining me.
Thank you.
And hi, Rafael. Thank you for joining me.
Hi, glad to be here.
I know that Analog Devices has a broad range of solutions for us working on robotics designs. But first, can you give me a high-level overview of what you guys offer?
I can actually tackle that first. So, what we offer is we have created a whole ecosystem around the whole mounted robotics end of arm tool functionality. When I say a whole ecosystem, I'm more focusing about how you control the motors, the actuation, how you do the perception with it, combined with the whole control of the perception piece synced with the end of arm tools. There are a couple of bullet points we have to be focused on while explaining this is the high performance of the motion control. So we provide a solution for precise motion control, including some motor drives for BLDC and servo motors. We have position encoders. We have our newly launched zero power encoder series. We have motors as well with the different NEMA settings. We can have NEMA 17, 14, you name it, we have it, ensuring optimized performances and reliable robotics movement. Complementary to that, what we also offer is we offer real-time awareness with our enhanced precision. What I mean by enhanced precision is with a technology such as time of flight that we developed in-house, what we are creating is we are creating a depth image for you on the edge that you can use to do the object detection while you perform the actuation to pick and place an object, as an example. As well as we have also created some enhancements with the tool change. So earlier, what was the major drawbacks that we have seen the tool changer used to have is the connectors. So the connector tends to bend or break. Now, they usually don't happen in a small time, but it eventually happens in the long run. What we have created is we have created a modular solution which you can connect to your end of arm tool, which can transfer data. Now, when I say transfer data, you can actually transfer data up to a distance of 5 centimeters altogether with a speed of more than a gig, which will help you enable your actuation much faster and in real time, as well as when the complementary real-time awareness, which we are offering with the time of flight, can also be linked to our high-speed data transmission GMSL connectivity. So combine all this together, we create an ecosystem that helps you achieve multiple things for mostly the precision control of your actuators, as well as a real-time awareness of your actuator complementing with a time-of-flight solution.
Just to add a little bit to that, so all the solutions which are focused specifically on the robotics market, we also do offer the software stack that goes with it, right? So it's important to note that most of the solutions in the industrial type of robotics, they use a thing called ROS, which stands for Robotics Operational System. And what you need for these to be integrated into ROS. So ROS makes it easy for you to integrate it all together, fuse the sensor data, do navigation planning, path planning, everything that you need for a robot could be done through ROS. And what we do offer with all the solutions that Rajan just described are ROS nodes, which basically facilitates the integration of these into the ROS ecosystem. So I think it's important to note that because it does make things a lot easier when you get to the step of integrating solutions, especially because sometimes you do need to test it out, you need to debug. So the faster you're able to integrate your solution into the system and make it work, the better. And we do offer a very big software stack that makes it easier for customers to integrate those types of solutions into their applications.
You mentioned motor control earlier, and that's a huge part of just about every robotic system, particularly in the area of grippers and so forth. So, can we dive down into specific solutions Analog Devices offers here?
Absolutely. So for the motor control, especially the areas like grippers, as you mentioned, we offer a wide range of solutions. And here are some key solutions that are mentioned over there. So the first one is the TMCM 1617 series. So what we have created is we have created a reference design as well as a complete miniaturized solution, a fully packaged single axis drive for three-phase BLDC motors. What we are offering with this is you can actually use the IC device on the background, and we are giving you a possibility to connect and make your own gripper with a reference design that supports a voltage up to like 8 volts all the way to 28 volts with a current up to 18 RMS. This module actually offers a compact solution for space constrained applications, which is grippers in this prospect, where you have to do a precise torque control and current control to achieve extra precision with your tasks. Offering to that, we also are providing our TMCM 1690 series. This is a board level servo drive module that we designed for BLDC motor specifically. It can operate up to 10 volts all the way to 60 volts DC, more like a flexible solution to customize design and offering robust control in a compact form factor. As you can see, it's a very small chip. The TMC 1690 also supports all the incremental encoders you have on the market, as well as digital Hall sensors and absolute encoders that helps you achieve position feedback. Just not this, our hardware offerings also integrate FOCs, field orient control, for precise motor control, as I mentioned before, ensuring the efficiency in the energy, as well as optimizing the torque ripple. Now, these solutions, as Rafael were mentioning, also comes with the software stack of ROS. So our TMCM 1617 series, we are offering a already ROS1 enabled software stack that comes with the reference design that helps you integrate it easily and faster in your system and reduce your time to market drastically.
Also, it's important to note that the offerings that we have, they range into different categories as well, right? So we have solutions which are IC level solutions. So it all depends on the level of integration needed by the customer. So if you're developing your own boards and your own hardware, there's IC level solutions. Then there is a step up, which is a couple of the boards that Rajan just showed in there. So TMCM 1617 grip reference design, it's a board level solution, right? So it makes it easy because then you don't need to do the IC integration. But then a step above of that, there is also a very big portfolio of what we call pen drives. So the pen drives are solutions which are motors plus the motor control plus the encoders. So it's very different levels of solutions which are offered for the robotics type of applications.
Vision is a huge challenge in robotics. Most of our robots need to see what they're doing, right? So how can Analog Devices help us with vision in particular?
Sure. So I'd like to start with a small overview of vision systems for robotics. We have 2D cameras. So there are 2D cameras, which are RGB and grayscale cameras, which could be used for object detection, pattern recognition, anything that a 2D camera can do. That's very similar to the camera everyone has in their phones. But then you have the domain of the 3D cameras and 3D perception systems. And if you think about robotics, you're thinking about actuators which are moving around, and they're making mechanical parts which are moving around, and they have to navigate around an environment, right? For that, you do need perception, right? Because you do need to avoid obstacles. You need to grasp objects. You need to do several types of different applications. And for these perception, 3D perception is needed. There are a few different technologies in that. Each one has their pros and cons. For example, you have LiDAR, but those are usually at a very high cost. And not only that, they're bigger. They do have movable mechanical parts. There is structured light technology, which again calculates the shape of the object by projecting a light pattern onto it and then calculating all of the distortions in the image. There are several different technologies. What ADI offers into this scenario is a step up from that. So our module is based on the time of flight technology. The way that works is basically you have a laser emitting a modulated pulse, which is going to bounce out of objects. And as soon as it comes back, we calculate the phase offset in between these pulses. By doing that, you're able to estimate with high accuracy and high precision what is the position of this object or the distance of this point into a pixel. The sensor that we have is developed in-house as a 1 megapixel sensor, which basically means we have about 1 million points. And for each one of those, you have the depth information coming out of it. And comparing with other types of vision systems, the time of flight accuracy is maintained throughout the whole operation range. So we work up until the range of 3.5 meters guaranteed, and then you have plus or minus 5 millimeters of accuracy. But this is maintained throughout the whole range of operation, which is a step up if you compare, for example, against technologies such as stereo vision, which uses 2 cameras to get the same type of depth information. So the module that you see in there is comprised of a few different parts, right? We have the ADTF 3175, which is the depth sensor itself and the laser. So it's a full module solution, already comes with the optics. The step up of that is the depth computation device. So the ADSD 3500 is what is doing the actual computation of the depth information. So basically it's getting the information that I just mentioned before from the modulated pulses, and it's doing this calculation for you. And then after that, there is just a carrier board which sends you this information through an interface. So it's a USB-C type of interface, plug and play. We give all the software stack for that alongside with examples. So this is very easy to integrate, whether you have a Windows system. Linux systems are very common in the robotics environment. So it's important that it works in a multi-platform manner. So these depth applications, it's very broad what you can do with it, right? So you could do object detection, as Rajan mentioned before. So let's say, for example, you have a robotic cell and you need to grasp different objects in there. You could get the height out of it instead of just using the regular, say, 2D vision systems, which are very common in the industry. But now we're trying to move a step up to the 3D systems, and this is part of ADI's offerings in there. This is already starting to get very much used in all sorts of robots, whether they are fixed robots, such as robotic arms and all types of industrial manipulators, but also AGVs, which are automated guided vehicles, or AMRs, which are autonomous. They have to navigate in an environment. And one point that I'd like to add is most of these robots, they're designed to operate in factories and in spaces which are designed for humans, and you have humans moving around, right? So using the cameras for depth perception is crucial because you do need to avoid obstacles. You do need to stop if you see someone coming at you or coming in the direction of the robot. So the depth is a crucial part of the systems, right? This type of solution reduces the complexity of integrating it because it does all the calculations for you, and then you have this raw data out of the sensor that you can use for these several types of applications.
All of these cameras generate huge amounts of data, which we also need to move around. So does ADI offer any real-time connectivity solutions for vision-related data?
Yes. So for vision-related data and any type of multimedia data, really, what we do have is a technology called GMSL. So GMSL stands for Gigabit Multimedia Serial Link, and it was a technology created focused on sending data of cameras and ADA sensor, any type of perception sensor, over a link and through a processing unit. The way this works, it's a SerDes pair type of technology. What that means is that you have a serializer on the perception sensor side, and you have a deserializer on your processor side. So let's say, for example, you have a sensor on one side and you have your processor side on one side. You would have 2 ADI chips in there. You have a serializer on the perception side, a deserializer on the other side. What this does is you connect the camera on the serializer side. It transforms the data to the GMSL protocol, and this data is sent over with a bandwidth that could go up to 6 gigabits per second to a serial protocol. So this is all over a coax cable, 2-wire cable, which is also very important for robotics applications, right? Because you do want to save space on cabling, and GMSL allows for that. So by sending this data over, it's a high bandwidth connectivity solution. You're able to send data of several different sensors, even over the same link, as long as it fits the bandwidth. So for example, you could connect a 1 megapixel time-of-flight sensor that I just mentioned and a LiDAR or a radar or any other sort of perception sensor, as long as it fits the bandwidth. And then on the deserializer side, the deserializer parts usually have more than one port, so you could connect several serializer parts onto it. And the interesting part about GMSL is over a reverse channel, which runs on the same cable, you're able to send power. So you're able to power your perception sensor. and you're able to send configuration data as well. So whether that is I2C, SPI, UART, several protocols are compatible with the GMSL protocol, and these runs on a 187 megabits per second speed, and you're able to send this configuration to configure a camera or your sensor as needed. There is also configure pins that you have on the serializer side. So you could power up several peripherals, you can connect sensors onto it. Any peripherals that you have on the board on the other side, you could also use the reverse channel to configure those, right? Other functionalities that are included onto the GMSL is a crystal-free operation. So to reduce the BOM needed onto the perception side, you're able to send the clock over the GMSL channel as well. So you don't need a crystal to do the clock on the sensor side anymore, because you're able to get this from the deserializer side, saving on BOM costs, saving on space. GMSL is also very robust to interferences, right? So it equalizes for temperature variations, cable aging, cable length. So all of these are included into a technology. It started in the automotive market. It came up as an automotive technology, and now it's broadly used in the industry. It's a ASIL-B type of safety certification. So it came from the automotive market, but now it's very reliably being used on the industrial market as well. There are several generations of GMSL. The ones I'm focusing in at the moment in here are the GMSL 2 parts, which are basically the latest ones available for the industrial market. And they are backwards compatible as well. So customers do not need to worry about new generations coming and they not being backwards compatible. You're able to use, let's say, for example, a GMSL 1 camera on a GMSL 2 deserializer without a problem. So you reduce cabling, it's safe, it's robust, it's able to auto-equalize for changes in the environment, and is able to give you a very robust communication protocol for perception sensors.
Okay, so let's talk a bit about Gigabit Multimedia Link, or GMSL. What advantages does GMSL provide over traditional communication methods in electric automation systems?
All of the topics that I just mentioned are basically benefits of the GMSL protocol, right? So not only you were able to reduce cabling, the industrial standards for GMSL are very robust. It's widely adopted already in not only in the automotive industry, but also in the industrial segment. The size is something that matters. All of the communication protocol is dealt with by the serializer and deserializer pair. So you don't need an external processing unit. Let's say if you had Ethernet, you would have the PHYs, and then you have a processing unit that would compute all of these and transmit that to the protocol. You don't need this in GMSL, so it's very easy to integrate. Also, we do have a very wide range of parts that vary in the specs that they offer. So according to the needs of the project, a proper part could be picked for the application, right? So it's a very robust technology. The power over coax as well is validated for several different levels of power. So you could fine tune this for your specific application. And also documentation, right? Documentation and the software stack that we offer is very robust, which basically means that you could integrate the solution into your system without a lot of effort. So evaluation kits are also available. So it's plug and play, right? There is a GUI, you connect the two boards in, you connect this to your sensor, and you're basically able to stream data without any effort. Plus, GMSL was made for perception sensors, right? So it was made to transfer data of cameras and perception systems, which is different from other protocols. So it's basically the protocol created for this purpose, instead of getting, for example, Ethernet or EtherCAT, which was not made for that, and trying to transfer multimedia data using the protocol, right? So GMSL was created for it. So every spec in it was made to make the transmission of media data optimal.
You actually summarized this very well. I would just like to touch base on one thing, the cost efficiency that is increased by using GMSL overall. The traditional communication protocols we have right now, you require multiple cables, multiple connectors, and that does pile up as a cost. Not just one robot. If you're running the whole manufacturing unit, yes, the cost goes up altogether. So GMSL actually helps to lower down that lower cost materials by just you can transfer data and power on one single cable. So I think it does make sense when you have multiple perception units to determine the real-time awareness of your systems. GMSL does come up as the best solution as related to the traditionals we have right now out in the market.
Well, I think that's all I have time for today. Thank you so much for joining me, Rajan.
Thank you.
And thank you for joining me, Rafael.
Thanks, Amelia. It was a pleasure.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Analog Devices. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.